Hi guys, this is my project for 15112. I have created a physics experiment simulator using Python and the Python tkinter library. So let's go through the project. So this is my basic interface that I've used that I've made using tkinter. It has four different experiments, that is projectile motion, uh, collision, magnification by concave mirror, and motion in vertical circle. So let's go through projectile motion. As you click on the button, a window appears asking us for velocity of the ball and the angle at which it will be launched. Let's enter the value and set the values. Once we click this projectile trajectory button, a new window appears where the ball is shown moving on the screen and under the influence of gravity. Once the ball reaches the ground, the projectile trajectory appears, which is parabolic in nature. The new feature that I added in this the experiment was once I click anywhere on the trajectory, the ball moves to that point and a new label appears which gives us the information about the horizontal velocity and the vertical velocity of the ball. And there are other labels to give the velocity, give the information about the range, height, and the time of flight. So this was the projectile motion part. Now let's go through the collision part. So I have taken in consideration all the types of collision: completely elastic, completely inelastic, and collisions with the value of coefficient of restitution anywhere between 0 and 1. Let's try a completely elastic collision. And let's set the values. Once we run the code, it shows us the two balls moving towards each other with velocity 20 and minus 20, and there is another label for the facts. And once the ball collide, the two balls move apart from each other with the new velocities, and there is no loss of kinetic energy because this is a perfectly elastic collision. You can do this for any values of coefficient of restitution. Now let's try another experiment for magnification by concave mirror. So in this case, we can enter any value of focal length for the concave mirror, and we can set an object distance and the object height. So let's set the focal length and the object distance and the object height, let's say 14 centimeter. After setting the values, we can run the simulation. So it shows us the object by indicating a O below the object and I above the image, and shows you the location of both object and image with respect to focus and center of curvature. Moreover, the program will give us the information about the focal length, object distance, image distance, the height and of the object as well as the image, the magnification, and the nature of the image, which is real and magnified. So you can enter any velocities for the any values for the magnification, and the program will work. And the final code is for the motion in the vertical circle. And once I run the code, it asks us for the velocity for the ball, let's say 7 meter per second, and 2 meter be the length of the stick. And then once we set the values and run the code, it shows us the board on which there's a stick hinged to a point and the ball moving with respect to the stick, and it gives us the reason why the ball is not able to complete the circle, because the velocity is less than root 5 gl and it's greater than the root 2 gl. That is related to the formulas. So this is regarding my project of 15112. I hope you like it.